Okay, so what we got here is a master cylinder. It's from 1978 KZ1000. I think it's from an LTD. This model has through holes in it instead of threads. I forget which model exactly has that. Some of them do, some of them don't. The unit itself is pretty badly corroded. You can see all the corrosion in here. You can't push the piston anymore. If I open up the master cylinder, the inside is all sludgy. Everything is full of, brown funk. But on the good side, the rubber and the plastic cap are actually in excellent condition, and the reservoir itself is also in excellent condition. So that makes this a really good candidate for rebuild, as those parts alone are very hard to come by without them being usually like badly white out, oxidized. Sometimes they'll be cracked. Sometimes people put solvents in here and there'll be actually spots where the plastic is like eroded away. So it's a good candidate. So to start, first thing we're going to do is pull out this plastic insert in the bottom and just use a hook and sort of grab it like so, and it'll pop right out. There's just little tabs on the outside edges that hold it in, and if you can see from here, it is full of garbage. So what we want to do now is just clean as much of this out of here as we can. So I'm just going to stick a rag in here right now and just soak up as much of this old oxidized brake fluid as I can. And there's a pretty fair amount of rust in here. So as you can see, it's pretty rusty. These screws are JIS. If you attempt to get these out using a standard Phillips screwdriver, you are probably going to round off the insides of them and make them unusable. Now, even with that said, there's a pretty good chance these are corroded into the aluminum to the point where I'm going to have to drill them out. But before we do that, I'm going to make an attempt using an impact driver to get these out, and I usually got about an 80% success rate of doing it that way. So what I'm going to do now is I'm going to clamp this into my vise, and I want to do it so I kind of this edge up against the back, because what that does is it stops it from being able to tip down, and you want it pretty dang tight. It doesn't move. Alright, coming back here, so what I have here is just an impact driver, and I use these Aries bits, and that's usually enough to get these out. So I'm going to get my driver in there, and right off the rip, that one turned. Try the second one, and that one turned. So I have my JIS screwdrivers, and take this out of here so we can see better, and we're going to take these screws out. Okay. Now I'm going to use my hook. I'm actually going to grab a different hook that's got a tighter 90-degree bit. You see here. I get underneath this aluminum plate and really try to get it, pull it out of here. There we go, started to turn, and I got it out. So now the only thing holding this reservoir in, there's an O-ring on the inside, and a lot of times the aluminum might also be corroded. So I'll put it back in the vise, slump it down, just grab it, and try to kind of rock it back and forth, and it'll usually pop out. You can see there's a fair amount of corrosion that was holding it in. That didn't come out too bad, but a lot of times you got to really work at them. On the inside here, there's a rubber O-ring. So I use my shallow hook, and I'll go underneath it, and I'm going to pull it out. Okay, so now we've got the reservoir end disassembled. I'm going to, next up what I'm going to do is I'm going to take this plug out of here. So I'm going to put it back in my vise, and at this point I want to be a little more careful with it. I'm not too worried about if I scratch up these faces, because there's a bolt that goes up against it and you don't really see it in the bike, but these surfaces you do. So I'm going to put a piece of paper towel around here and just sort of double it up. So the jaws of my vise aren't marring the end of this, and actually I'll do it over here where it's a better view. So I got a good solid bite on it. You want to be careful not to clamp on this aluminum tang, because you'll end up breaking it off. So now I need a 22mm socket. And I'm just going to grab a breaker bar and then pop this plug off of here, which that came off pretty easy. And you can see there's still fluid inside of this. I'm going to dump this. I've got a trash can over here and dump it in. There's some pretty nasty stuff inside of here. Pretty goopy. So next thing we got to do now is try to get this piston out. So I'm going to put it back in my vise again. And we're going to start with our shallow hook. I'm going to move this over just a little bit so you can probably see this better. And we're going to hook it under the one edge. You can see it kind of pulls away from it. And you want to roll it up towards the top. Roll it up towards the top of that, and then you just sort of work it the rest of the way out. You can grab the other side as well. Give it a little roll. And then sometimes just use the pliers. Once you got it rolled up like that, you can just sort of spin it out. Underneath that, there's a washer. Now, this washer is like really seized in here. So I'm going to take a screwdriver and I'm going to kind of tap on the end of it and try to loosen up some of that rust. I'm not hitting it very hard. Obviously you can see it moving in the vise a little bit, but now if we get a grip on it, I can get it out. So now we're to the point where the only thing we got left is this piston. There's a piston, seals, and the springs in here. And from what you can see here, I'll take it better from the camera. There is no way that that is just going to fall out on its own. Normally the spring pressure would allow you to move it. So we're going to try a different trick, and I will be back in a second to show you that. Okay, so I've got my tools together here to try to get this piston out. And what I have is a 3/8/16 tap, my tap driver, short length of 3/8/16 threaded rod, a nut, and a couple washers, and a wrench. So what we're going to do here is we're going to take the tap and we're going to start out by the center, by tapping some threads into the center hole in that piston. And that piston ID is at just about the perfect size for a tap drill diameter for a 3/8/16 tap. So we want to take our tap and get it, you want it lined up as straight as you can with the piston and start to screw it in. The piston is made out of a zinc alloy, which is very, very soft. So it's really easy to get the tap to screw in here. And I typically don't even bother lubricating it because the zinc actually will just do that on its own. So you want to go in there as far as you can. Once you start feeling resistance on it though, you want to stop because it's bottoming out and you don't want to strip the threads that you're trying to make. So now that I'm in there, and I'll take this out of here, there is a bunch of garbage in the bottom, so I'm going to go and tap this in my trash can and clean that out. And I'm going to hit it one more time with the tap and go in as deep as I possibly can here. So I'm going to restart the threads. Be very careful when you restart them. And hopefully I can get probably another, well, actually no, I can't get another thread. That's pretty much bottomed out. So pull that guy out. Clean it one more time. And then we're going to do a similar trick to what I've done in some past videos on how to get out seized needle and seat valves. So we're going to take our threaded rod and we're going to screw it in as far as we possibly can here until it bottoms out. And basically we're making a reverse gear, like a reverse gear puller. So now that I have the nut pulled in, when we tighten this up, it's going to pull the piston up. So I'm going to just turn this. You can see it's actually turning pretty easy. So keep going until that nut bottoms out. And now all of a sudden the whole thing is spinning now, so it's almost all the way to the top, and I can get my piston to start moving now. Almost out. Now, if your piston seizes up, you can always take this and back this nut off, and you put a socket around this, and you use that almost like a puller to pull the piston up into that if it's so seized up that you can't get the end of it past the end. This one is actually loose enough I can rock it out. So here is the remnants of my piston, which is pretty nasty. Theoretically, we could reuse this one because I don't see that much scoring on it, and even with these threads recut in the middle, it won't make a difference. But the issue is getting this seal. The KZ1000s are, it's a 16 millimeter cup seal. There's also a 16 millimeter cup seal at the base. These I haven't been able to find. But what I can find is through Brake Crafters, and then there's one other company, I forget what their name is. They sell a kit for this master cylinder that comes with the whole piston assembly with the cup seals. And the kit is about $66, and I usually just buy the kit because the kit comes with the piston, both the seals, and it also comes with a new washer and a new ring and a new spring to go in the bottom. So it's all the inner components that go with this, and it makes the rebuild really easy. On a KZ650, it's a very similar setup in here. The problem with the KZ650 is this cup seal and the end seal are a 14 millimeter seal, which aren't available in that kit. But what you can do is you have to reuse the piston in a KZ650, and then you buy the seal kit for a KZ650 front master cylinder, which is a 14 millimeter master cylinder, which are available, and the cup and the cone seals are exactly the same. So you would have to take the seal off, swap them in, and then you can replace it. So getting back to this, now that our master cylinder is completely disassembled, or close to it, there's still a cup seal in the bottom. So I'm going to use my hook, and I'm going to go in the bottom, and I'm going to see if I can hook that seal. I'm going to grab my other hook here, it might be a little easier. I'm trying to do this without scratching the inner bore, if you can avoid it. So this is the cup seal, and amazingly, even though there's so much gunk in here, it's ridiculous. These seals are actually in pretty good shape. It's just everything is just so gummed up that it's hard to tell. The next thing I'm going to do here, I'm actually going to take this out of here and just dump. There's my spring. So, and amazingly too, the spring is also in good shape. It is not rusty at all. It is just got a bunch of, kind of gelled up brake fluid on it. So I'm going to try to see if I can get a view on camera to show the inside of that bore. I'm going to grab a flashlight here so you can kind of see what's going on in there. Now, I don't actually see a lot of corrosion in the bore itself, so we might get lucky on this one and be able to do a rebuild on it with just a cleaning and do seals. A lot of times on these you end up with corrosion that's down in the bottom of the bore where the seal cups make contact. If you have pitting on the sides, you can hone it with a small brake cylinder hone to about it's about, I usually don't go any more than about 5/1000 of an inch bigger than original. If you can take it that much and then get the pits out, then you can reuse it. If you can't, then we have to sleeve it, and that is actually a whole nother video. So for right now, I'm going to set this up, and I'm going to try to clean this in my ultrasonic cleaner to get all this goop out of here. And then once that's done, we're going to take this and we're going to put it in the vapor blaster and blast the outside and make it look all nice and pretty again. Okay, so what we're going to do now is we're going to grab all of our parts, and we are going to go over by the ultrasonic cleaner. And this is just a kind of a plain Jane Chinese ultrasonic cleaner. This is a bigger one. This holds, I think it's a 30 liter. I do like it because it actually has a lot of wattage, so it does a good job. I also have a Sharper Tech and then a couple other smaller ones that I use occasionally. So I just fired it up, so the temperature is a little low, but what we're using is we're using Sharper Tech carburetor cleaner. Works pretty good for this. And never mind, that's my heater in the back kicking on, making that buzzing sound. I found that works pretty good. It doesn't corrode the aluminum, is the main thing that I'm looking for. So we're basically going to just dump everything in here and try to put the dirty sides down, more or less. And then the cap, actually, you know what, we're going to hold off on the cap. We might just put that in a different machine. But the stuff that's really grimy, I'm going to put in here. And then I also have a filtration system on here that I'll run occasionally to get the grit out of the ultrasonic cleaner. So we're going to let that go now for 30 minutes or 29 minutes. Okay, so now we've ran 2 cycles of 29 minutes through the ultrasonic cleaner, and obviously the more it runs too, the hotter it gets. So we're actually up to 51 degrees Celsius now, which is good, and it'll start to steam a little bit. Pull this off to the side here, and we're going to pull our ultrasonic thing out here. Now, let's try to get this better in the light. It's still pretty goopy inside, but it got rid of all the loose stuff, which is the main thing that we need to get rid of. A lot of this white corrosion, the ultrasonic cleaner will not remove that. I do have another chemical I'm going to try to run, which is it's called Crud Buster, and it's also made by Sharper Tech. It's a bit more corrosive. I keep that in this other cleaner here. I usually only try to run that for like 1 cycle, because if you're not careful, it will start to pit the aluminum, which we obviously don't want. If it starts to pit it, then we end up with scores in our bore and whatnot. But what I'll do is I'll usually give it like 1 25-minute cycle, and then whatever corrosion is left on here is stuff that we're just going to have to mechanically remove. So that's going to go in that, and then just stand it up like so. We'll start this, and I'm going to set it for 20 minutes. My temperature is set to 35 degrees Celsius. Right now it's 18 degrees Celsius. It's a little cold, but it'll still work fine. You'll find it's warm after that first cycle. So we're going to set that, and we're just going to run it sometime, if it'll start. Let's see here. There we go. And we will come back in a few minutes. Okay, so while the main body is running, we pulled these parts out of the ultrasonic cleaner, and these came out pretty good. You still end up with the plastic sometimes. I don't know if you can see this or not. You still end up with a little kind of this brown crud in the corners that doesn't want to come out. But that stuff is pretty well sealed in there, and it doesn't really come back out. I can go in with a pick and I can get the last of it, but getting in that very corner is pretty difficult, but it usually doesn't cause any problems. The other issue with the plastic is it always ends up getting kind of stained, kind of this brownish color, and it yellows. I haven't found anything that gets rid of that. I tried a bunch of different processes. I tried using bleach. I tried using peroxide. Somebody said it would whiten the plastic. I tried some different cleaners. I haven't yet to find anything that actually will finally change the color of this to the white color. So unfortunately it just is what it is. I do find though a lot of times on these bikes, the side that was facing the sun is the worst. So when I put it back together, I'll usually switch it to the other side, so if we have a restoration job or something that's going on to it, at least the nicer side is out. The rest of the components came out really well. The cap looks really good, with the exception of a bunch of scratches, but that's not bad. The rubber is in good shape. There's no holes or anything in it. The aluminum piece, there's a little bit of oxidation on the edge, and what we're going to do with that is we're just going to put this in the vapor blaster when I do the other half, and that'll get rid of all that. The inner seal for the cap, that came out perfect. This screw in particular, this one I'm going to put off into my miscellaneous or my extra parts bin. When I accumulate enough of these, what I do is I blast them, and then I replate them, usually with either nickel or zinc, depending on if I have enough that I can send them out for zinc. I don't do zinc in house, but if I only have a few, I'll do electroless nickel in house, and I keep kind of a stockpile of these. when I get like 5 or 6 of them, I'll replate them so that I have them in my parts bin for the next time. And the same thing with these wave spring clips and the washers. I do the same thing. It's not such a big deal with KZ1000 because when I buy the parts kit, it comes with replacements to these. But when I get a KZ650, it doesn't come with these because I'm just buying the seals, and I have to reuse a lot of the components. So I'll save these wave washers and these for the next operation for that, and just replate them. And I keep a small supply of the seals for the KZ650s as well. So for right now we're just waiting for that to come out from the second run on the ultrasonic cleaner, and then I will show how we do the vapor blasting on it. Okay, so this just came out of the other ultrasonic cleaner with the shellac buster in it. And I went through and I kind of scraped a little bit more of this white corrosion that just doesn't want to come off. That usually doesn't come off in the ultrasonics. It'll get some of it, but not all of it. Aluminum's kind of funny. Like if I put steel in here and I got rust on it, I can put it through and it will remove the rust and it'll make it clean. But on the aluminum, this aluminum oxide and then this combination with that and the brake fluid, it just makes this paste that doesn't want to come off. So that's all right because we're going to blast it off in the wet blaster. Before I put this in a wet blaster though, there's spots that I don't want to blast. The wet blaster, or vapor hone what they call it, it's a VHT micro hone that I use, uses glass bead media, and I don't want to damage the surface finish on the threads or in the main bore of this. You really don't want it getting into the threads either, because what will happen is if you leave even the tiniest bit of that glass bead and you screw a bolt into it, it makes the threads gall up, and it might destroy your bolt or the threads in the part when you take it back out. So what I start off with is I've got a bunch of sacrificial hardware, that's what I call it, that I use to plug off all the holes. So I'll plug off the main line hole, and then I will plug off the hole in the side. In fact, I'm going to use the original bolt because it's actually kind of crapped up anyways, and if I blast it clean, who cares? Because there's no good plating left on it. So plug up that hole, and I've got these two smaller holes in the middle that I'll put some screws in just to keep the media out of the threads. And then last but not least is the end, so the main cylinder housing. So what I have is I got an old piston that's actually broken, and I'll just stick this down in here, and I gotta just use a bolt to kind of stick it down in there, and that will keep the stuff out of the bottom section of the bore where the seals make contact. This upper section here, if the finish on that gets a little distorted, it's not that big a deal because really that's a guide for this inner piston. There's no rubber seals that are making contact with this larger surface. So my goal is just to get it clean so I don't have all this white corrosion coming out of it. So now that we got that all set up, we're going to go over to the vapor blaster. So I'm going to pull this down, and here we go. So we are going to go over to the vapor blaster. So here is my VHT micro hone, and we're going to open up the top and set our part down in there, and then I am going to go get my light and get this reset up so you can see what's going on. Okay, so I don't know how well this is going to come through, but we're going to try to see if we can film the vapor blasting process. So I've got my parts down in here. So I'm going to grab my wand and I'm going to start the vapor blaster. So So I'm going to start off by trying to see if I can get as much of this crap out of the inside. As possible. You can kind of see how it changes the color of it. So I'm going to stop the video here and then come back when it's done. Okay, so now it's came out of the vapor blaster and it looks really good. There's obviously some pitting in these areas here. I don't want to keep hitting this because I don't want to mess up the bores. So that's about as much as I'm going to clean up with the vapor blaster. The rest I'm going to do with mechanical honing. So now that there's still a little bit of like grittiness, so I'm going to take all these screws back out. And then it's going to take another bath in the ultrasonic cleaner. And then I'm going to run the pump on the other cleaner and then filter out the glass beads as it runs. Because I don't want that contaminating my fluid. And then also redepositing inside different spots in here. Okay, so now we pulled it out of the ultrasonic cleaner for the last time. And I ran a blowgun through it to blow all the loose water out. Now the side where the reservoir goes in is pretty clean. There's a couple little spots still down in there. I'm just going to give it a little scrape. This side, there was obviously pitting around this corner because there's water that tends to sit inside there, and it will sit up against the rubber boot that's on it. And when I got this, there was no boot left on it, so I don't know how long the boot had been off. But as you can see, there's a fair amount of corrosion on the inside here. I'm not going to hit this with the wet blaster because I really don't want to damage that surface. So what I have is just a brass brush on a little rotary tool. So I'm going to go in here and I'm going to clean the rust out of this groove just real lightly. And the brass brush seems to do a pretty good job of this. In fact, I'm going to use it on the other side too to get the last of the corrosion out of that O-ring groove. And I'm going to just come down that whole surface. You see how it just sort of loosens that stuff up right away and gives a nice polished finish. And doesn't really seem to erode away the aluminum. And I'm going to hit this inside surface here. And a little bit more right here. Okay, so now those two sealings, that sealing surface is clean, and my groove where my snap ring sits and my washer are nice and clean, and then my guide surface here, a little bit of corrosion I'm going to get off. Yep. Make sure that's all nice and clean. Like I said, I'm only going in there up until that first step, so where the larger diameter is. I do not want to hit the surface where my seals hit. I do not want to hit those with the brush. I don't want to leave spiral marks in there or anything odd. So the next stage is to polish up my bore where the seals sit and check to make sure I don't have any pitting. So I'm going to set that up next. Okay. So now what I got here is I have my hone, which is just it's a small, it's supposed to range down to 14 millimeter brake cylinder hone. I haven't been able to find a really good one of these, and this one even isn't really very good. I have to modify it a little bit to make it work correctly. Biggest complaint I have is once you get down that small, there's almost no spring tension. The other thing is the way that the stones are made. Occasionally these corners will drag on the inside of your cylinder, which will leave a big scar. So I never use these as is. What I usually do is, this is 600 grit wet dry sandpaper, and I'll just cut off a piece about 1.5 inches wide, about 3 inches long, just tear it off, and then I'll wrap this around my stones so it goes out past where the holders are. That way I never have a steel on steel contact. So then I want to push this in and then make sure it slides good. I'm going to go full speed and just rapidly move up and down. And you want to look down in there and make sure your sandpaper is still on your stones. If you feel for some reason like something's grinding, stop immediately before you leave a scar. I usually give this about a good 20 seconds or so, up and down. And then I'll pull it back out, grab a flashlight and just check and see what that bore looks like. Now it's probably pretty hard to see on the video. I'm going to try to snap some pictures a little bit later, but looking down in this, I'm not seeing any pits, which is good. And that's the main thing you're looking for, is the surface pitted? It should be shiny all the way down, and there shouldn't be divots and dents in it. A lot of times, depending on where that piston sits in there, you'll get an electrolysis reaction between the material of the piston and the material in your cylinder, and it causes like a little ring to get eroded into your cylinder. But when you have that ring, your rubber seal gets stuck on it, and that causes excessive wear on your seal, or in some cases it won't even seal in those spots. So you need to have what they call it, like a 62 RA finish all the way down that surface where that piston moves. So right now I'm looking at it, and I've got a couple little spots that are discolored. It's kind of whitish colored, so there's a little bit of corrosion, but I'm not seeing any major pits. So what I'm going to do here is take my sandpaper, and I'm actually going to kind of clean it. Because what happens is, where my high spots are my stones, that's where it makes contact with it, and then it gets plugged up. So I'm going to clean it up, I'm going to wrap it again. And the other thing too is, because it spins this direction, you want to spin your sandpaper on there the opposite way. That way it gets tighter on the stones as it spins instead of looser, or else it'll just come flying off inside of there, and then you end up with leaving scars from your stones. The other thing is, usually on the final couple passes here, I'll put a little bit of oil on that sandpaper. So what I got here, this is just 30 weight oil. It's nothing special. I'm getting my thing to pump here. There we go. Just plain Jane 30 weight engine oil, and I also use this for cutting and drilling and stuff. You can use honing oil or something finer, sometimes works a little bit better. I'll just put a gop on there and kind of rub it around so it lubricates my paper. And the other thing that does is it keeps the aluminum from clogging your paper as bad. So I'm going to go on the second finish here. Get this a little tighter. There we go. Okay. Get that in there. Ooh, I gotta get that a little tighter than that. It's not cooperating right now. It helps too if you kind of have it kind of cone shaped a little bit on the end so you can get it in there. There we go. Now it's in there. So I'm gonna give this another pass. And probably about 30 seconds. Now this one, the cylinder was in pretty good shape. I didn't see any major pits or anything that I had to go like, that I actually had to take extra material out to get rid of. So this, as far as the video goes, this is a pretty ideal one to rebuild. Okay, so we're going to look down here. And looking down this bore, it just needs a little bit more, but it's pretty close. I'm actually going to up my grit. I'm going to go to a 400 grit, which is a little bit coarser, just to take off some more of that corrosion that's on there, because I'm hoping there's not a pit underneath it, but it's still got a little bit of white corrosion. And I just went the wrong way with my paper. I gotta go this way. There. And we're going to take that off. And it pays to be thorough when you do this. Don't just say, okay, well that's good enough, and I'm gonna call it a day, and you know, hope for the best. I mean, at the end of the day, this is a brake cylinder and it's a safety device. So make sure that you're doing this correctly and you're not seeing pits in the bores, and go from there. Okay, let's take another look. Oh yeah, there we go. That took it right out. It took it right out. So I don't see any major pits. Everything looks nice and shiny down in there. I will do one more pass with the 400 grit in the oil, just to give it a little bit of to shine it up just a little bit more. And in this one, we're gonna call it a day on that bore. And then after we're done honing, I'm going to set up a bore gauge and I'm going to physically measure these bores and check it for concentricity or being out around, and check it in multiple different spots to see if it's more worn in one than the other, and whether or not it's still within spec. Now I don't have manufacturer specs for these. What I do is I just kind of average it from other specifications I've gotten on 16 millimeter master cylinders. So we're unfortunately KZ and what was it? Who makes this? Tokido, or manufactured these for Kawasaki. Never released what the actual manufacturing specs are. As far as I know, they haven't. Unless there's somebody has that, I'd be interested to see it. But I'm going to go in here now, and I'm going to carefully push this rag all the way to the bottom without scraping that, and pull back out so I have a nice clean bore. And looking back in there, and that looks pretty fantastic to me. I think that'll be good. Alright, so now we got everything polished, so I had to get out my next tool, which is a bore gauge. This bore gauge is increments within 1/10 of a thousandth of an inch, so every one of these marks, the hole numbers are 1/1000th of an inch. So I've got my micrometer set up at 16 millimeters, and I have this set up to 0 at 16 millimeters. So what I'm looking for is to see that it's not going past 5/1000ths of an inch. That's my typical tolerance. On other cylinders I've seen, it was typically 0.1 millimeter, which is about 3.9 or thousandths of an inch. I usually go about plus or minus 5. That's the only one I have a spec for, unfortunately, and I can't get a specification for here. I've never had an issue with a failure as long as it was still within 5 thousandths, so that's kind of what I stuck with. So we're going to check this guy. We're going to go in here, and we're going to start it towards the top. So I'm at about 3.5 to 3 3/4 thou. I'm going to give it a rotation because I want to see if it's round. And it seems pretty good. So now I'm going to turn it up at a 45-degree angle because I don't want the gauge to drop into the pit in here. And I'm going to check it more towards the bottom where the wear surfaces are, and unfortunately I just dropped it into the damn pit. Which I did it again. So I'm going to check it down here. I'm going to rotate it just a little bit. So it seems pretty good. It's got a little bit of taper to it, but it's not anything I wouldn't expect. So the upper surface where it's not as worn is about 1 thou bigger than the bottom, but we're still within plus or minus 5, so we should be fine with it. When I check the bore now after I polished it, the bore looks really good. It looks nice and clean. It looks nice and shiny. So I think we're good to go. Now, if this bore was excessively pitted, then I'd go into it with one of these, which is a spiral hone. I've got a couple different grades. This one here is actually a little bit bigger. This is a 16 millimeter. I think it's a 400 grit. And this is actually a 15 millimeter 1200 grit. And even though it's a 16 millimeter bore, this will still fit, but it gives a real light coating. So if I had a lot of pits, I go in there with this and try to get the pits out, and then polish it with this, and then go back with the sandpaper again. As long as I'm still within my tolerance, I'm fine. Unfortunately, if I got to take it out bigger to the point where it's out of tolerance, then I have to sleeve it. That process involves I usually use a stainless steel sleeve, which is this is the tubing that I use typically. Now the bore on this is 16 millimeters, and then it has a 1 millimeter thick wall. So I would set this up in my milling machine with a 18 millimeter reamer, and I ream the hole all the way down to the base of it. Then I take this, I cut off a piece of this tubing to the length of that. I clean everything out, and I take this tubing and I put it in the freezer, and I try to deep freeze it. And I have another mandrel that I can hammer this thing in. And the reamer I have cuts 5/10 undersized, so it's an interference fit. When this fits, it will press in, and then I go back with the hone again, and I repolish the bore on it. So that's how I fix ones that are damaged to the point where the aluminum is out of spec on it. And then after this is put in, I have to go in with a drill and re-drill the 2 holes in the side through here, and then repolish it again. I've done a number of them that way, and I've never had one fail, and it always works out really well, especially with this tubing. I'll put a link to where you can buy this from. This is just off of Amazon. It's nothing special. It's just 304 stainless steel tubing. All right, so we're back to our master cylinder project. Everything's been cleaned, and we checked the bores. Did a little bit of honing. There was a couple little spots that were a little questionable, but everything kind of polished out good. And we checked the diameter. There is a little bit, or there's actually quite a bit of pitting on this back surface here, but in reality, it doesn't really matter. It's all that's done is that's where the boot attaches to it, and the section where the boot seals is actually pretty good. So we're going to put a brand new boot on it anyways. When the whole thing is complete, it's something you don't really see. So this thing's pretty much ready now for reassembly. So what I did, this is a KZ1000 LTD master cylinder. I usually go with these kits. I get it from Brake Crafters, and this is not a commercial necessarily for Brake Crafters, but they sell this kit. They're about the most inexpensive that I found, and everything looks like it's really good quality. The There's a couple, I think Z1 sells one, and there's a few other motorcycle restoration houses that sell them. So that's the part number of the kit, and I'll show you here. Comes with a little dab of the red rubber grease for putting it together. Comes with a sticker. Comes with new seals for your banjo bolt. And here, I'll open this guy up. Pretty much comes with everything else you need, the exception of the side bolt. So we get a new cup seal. We get a new rubber boot to go on the end. Comes with a brand new piston, machined and anodized. Comes with the main cup seal, which we have to install on here, which I'm not quite sure why they do it that way, but there is this can be tricky. If you're not careful when you install this, you can tear it. Comes with a new end washer, new spring, and a new C-clip for the end. So pretty much all the wear components. So to start with, what I'm going to do here is I'm going to install this cup seal. So I'm going to take a little blob of this red rubber grease, and I'm actually going to put it on the outside of this piston surface. I'll wipe my fingertips off. I want it to lubricate it when I put this on. I don't want it to accidentally tear. So really all you do is just sort of start out with it sideways and gently push it over the top. You want to kind of be super careful not to really drag it too hard on these metal, this metal valve on the end. Then you just sort of pull it down, and that's really about it. I'll usually wipe this grease off of the end of the piston because I don't want it to coagulate up under the valve, but we will grease up the cup seal just a little bit. And that's just for initial lubrication for installation. I do the same thing with the other cup seal that goes on the far end. Just putting a little bit of this red rubber grease on it. You want to use the red rubber grease that comes with the kit. If you're rebuilding one where you're reusing the seals or getting a seal kit from another place that doesn't come with that, you got to use either like the red rubber grease or a silicone-based grease. You do not want to use petroleum-based grease in it because it's not compatible with the brake fluid. And it also is not good for your seals. So next thing we're doing is we're going to drop in the spring. You want the metal side up towards the piston. And we're going to take our piston here, or our cup seal, and I'm going to just drop it in. Now I usually just take a screwdriver and sort of flip it over. And you got to kind of push it halfway in and then turn it back over. So you're kind of pushing it. You want it to stay flat so the cup side faces down towards the spring. So I usually try to get it down in here, flat up against the spring. It's probably hard to see. Let's see here if I can get a better view this way. But you can kind of see it's flat up against the face of the spring. So the next thing we do is insert the piston, and that will push up against it. And it should move freely when you get it in there. Okay, I had to do a reset. So now we got the piston in the bottom, or the cup seal in the bottom. We're going to insert our piston. So you gotta push down, make sure that it goes in. Now we kind of need a third hand to put the washer and the clip on it. So I'm going to use a long screwdriver. I'll put the washer around it, and then I'm going to go in the middle of the piston. And I'm going to push this down until the piston is just below the stopping surface where it would hit this washer. And I'm going to use my bench vise. To hold the screwdriver in place so it has pressure on the master cylinder. Oops. Helps if I drop the washer down first. Okay, so it's locked in. So now we can set our washer down in here. Get it down flush. And we can put our clip in. Now you can just use a needle nose pliers and sort of pull. You get two edges started first on this side, get down in the groove, and just use the pliers and sort of pull it in. So you pull in the one edge and then you just push it that, and then push it all the way to the bottom, and it should just snap right in. That's it. So now our piston's reinstalled. If I push on it, I got nice smooth movement. Okay, so we've got our piston in. The next part of assembly is the side plug that goes in here. This plug is pretty rusty. I really don't want to use it right now. I usually wait till I have like 5 or 6 of these, and then I'll strip them and then replate them. So I keep kind of a little stockpile of replated ones in the background. And this has been stripped and zinc plated. This is a 14 millimeter by 1 millimeter thick copper sealing washer. I literally buy these off of Amazon. There's nothing special about them. I've been using them for a number of years. They seem to be plenty soft. They do a good job of annealing them. So that just gets reinserted in here like so. And then the same kind of vise trick we did before. We want to wrap it in a towel or wrap it in something thick, so we're not just gouging the crap out of the aluminum. I'm just going to kind of gently tighten it a little bit. And then I got to torque this guy down. I don't know what the actual torque spec is for this, and I haven't been able to find it. I torque it pretty much just kind of hand tight. I'm probably right around 20 to 30 foot-pounds. It seems to work fine. I haven't had one that leaks, so. You do got to make sure though that surface is nice and clean before you start, or else you're not going to get a good seal. So the next thing is, there's a seal inside of here for your reservoir, and this old one is in pretty lousy condition. So this was a little trial and error to figure out what worked the best for these, and this is what we end up using. It's I actually just buy this from the O-ring store. It's a 2.5 millimeter by 47 millimeter ID Buna N70 metric O-ring, and that seems to work just fine. So kind of do the same thing as the cup seals on the inside. Once we get this in, we're going to lubricate it with some of that red grease. But you basically just get it down into the groove. You kind of have to fold it in on itself a little bit, but it should sit in there nice and flush. And then I'm going to take a little bit of this red rubber grease again, and I'm just going to smear a little bit on this edge. It just makes inserting that plastic reservoir a lot easier, and then you don't run the risk of it rolling the O-ring out and scoring it. So then we'll just take this guy and line up the holes in it and just sort of press it in. You kind of have to rock it a little bit sometimes, but that one actually went in pretty easy. And you just turn it till the holes line up. The bottom we have our plate, and it's basically just a flat plate. I'm going to flip it upside down so that the one side that's a little rust colored is kind of on the bottom. It's just so it looks better. Set it on the bottom. Now our original screws, we could reuse these, but they were completely rusted on the top, and the ultrasonic cleaner, the chemical I have in there, will take the rust off, but now it's bare steel. So if I do use these, they're going to start to rust again. I'm going to save them off to the side. I might replate them, I don't know. But I do have another set of 6mm SEM screws that are stainless steel. I'm going to use these to hold this down. They're a little different than the originals, but in reality, all it's doing is pushing down on this aluminum plate and holding down your reservoir. So it doesn't make any real difference as to the way it goes together. And I like the stainless screws anyways, just because later on down the road I don't worry about these corroding. So put that guy in there, nice and tight. There we go, and our reservoir is back on. Now one thing I didn't do, and actually I'm going to do here, this side is the side you see when it's installed on the bike. This side isn't. Now if you can see, this is the reservoir side is kind of all yellowed and corroded. That's from sunlight and just oil and crap getting splashed on it. And that side looks really nice and clean. So I'm actually I'm gonna take these screws back out and I'm gonna turn it 180 degrees because I want if I'm putting this on a bike that's been restored, I want to see the nice side of it. I don't want to see the crappy side. Turn it like that, and now we got a nice, almost white side to it. Put this guy back together again. And these stainless steel SEM screws, there's various places online where you can purchase them. I usually buy them in bulk. I've got a bunch of different sizes because I use these in carburetors too for float bowls and all kinds of stuff. And if you buy them in bulk, if you plan on doing other rebuilds or things, you can get them relatively inexpensively. So, next thing is the plastic spacer. The side with this little nub goes down, and then you have little tabs on the outside which have to line up with tabs in here. So you kind of want to set it down in there and you line the tabs up and you just push it down with your finger and it should just snap right in there, and it should sit like that. So now it's installed. Now it's just putting it on your cap again. Your cap is, you got your cap, and then you have your bellows. Or wait a minute, I have that backwards. You have the cap, you have the plastic washer goes in here. That should sit all the way in the bottom. And then the lip should be pointing up. And then you have your rubber bellows. Goes in there, make sure it's seated all the way. That goes back on. And then pretty much all that I got left now is just some ancillary hardware, because I'm sending out a rebuilt master cylinder. I want to send it out with new hardware. So I've got these banjo bolts, just an M10 by 125 plain Jane banjo bolt. There's a bunch of different places you can get them. I usually buy them in these bags of 5. I think it costs like $18 for 5 of them. And then I'll use the copper washers that were shipped with your rebuild kit. So if I'm going to send this out to a customer, it'll have new washers and it'll have a brand new banjo bolt on it. So, and then you got your last piece is just your rubber boot that goes over the bottom. So that you just sort of pull over the bottom edge like so. And that's it. That is your rebuilt master cylinder. Now this one was, like I said, this one was pretty easy because the bore was still in good condition, and all I had to do was just hone it a little bit. A lot of these are corroded to the point where that bore is so pitted and destroyed that you can't do that, and you can't expect it to reseal. So you have to put a sleeve in it, bore it out and put a sleeve. I will do another video the next time I get one that requires a sleeve, and I'll go through the process of how to make and install a sleeve and where to get the materials from. But I hope that explains the basic rebuild, resealing process of these master cylinders. I hope it helps somebody out. Have a good day.